Our next speaker comes from 3D HUBS. She is a product manager at 3D HUBS and holds a bachelor's degree in aerospace engineering and a master's in innovation management. Please welcome Agata Lovrecich. Thank you.
Thank you. Hi, good afternoon, everyone. Today we're going to be speaking about all the cases that you can consider in which you can use 3D printing not only for prototyping but also for end-use parts. But first of all, just a little background as to why I'm standing right here in front of you. So I work for a company called 3D HUBS. We're an online, on-demand manufacturing company that essentially provides immediate access to engineers and designers around the world to manufacturing facilities around the world for all different technologies, including traditional technologies like CNC machining, injection molding, and sheet metal, and also, of course, 3D printing. So when I say we provide immediate access, I mean that we provide immediate pricing, immediate design for manufacturability feedback, and also immediate production of parts. In the past 6 years, we've manufactured more than 3 million parts. Only this year, we've printed 750,000 parts. We offer technology, all the different main 3D printing technologies, including FDM, SLA, SLS, CMLS, and what have you. And more importantly, we work with engineers around the world in the top sectors around the world. So we've worked with around 120,000 engineers in different industries, and we've seen very interesting cases in which they have used 3D printing not for production, prototyping only, but for production. And these are a few considerations that you can think about when you're thinking about your project to see if it's plausible to use 3D printing and if it will actually be useful for your project. So the first one to consider is if you need design flexibility. Now, I'm not talking about design freedom, I'm talking about design flexibility. So what does this mean? It means, like, of course, prototyping is namely you iterate your design, you finalize the design, and you put it into production. And usually at that point, it's very hard to actually change the design and make any additional iterations to optimize the part for whatever you're using. But sometimes it's useful to actually be able to change the design after you start production. So that would be a very good case in which 3D printing actually would kind of be better than any other traditional type of manufacturing like injection molding or CNC machining. So an example of this is one of our customers, Manus VR. It's a company that does VR sets for training. And what they did was that they printed with MJF. They printed some parts for their training sets. And they did this because they wanted to be able to be flexible after they start production, right? So they don't want to have a set design that then, if they gave feedback from their customers, like, oh, this part is not ergonomic enough or it's not comfortable enough, they couldn't change it. So that's why they went for 3D printing instead of injection molding, which would be what you would consider initially. The second part, and I guess this is a little bit more the most common one, is you need to consider whether you're actually being constrained by the manufacturing constraints for your parts. So of course, sometimes it actually doesn't really matter too much. You don't want to over-optimize your design for function. So optimizing design for manufacturing is completely fair. But there are some cases in which optimizing your design for function is very, very important, and we usually forget this because we're so constrained by traditional manufacturing technologies. I think we've spoken a little bit about this before already, but just to reiterate, this is a good example. Part consolidation, essentially. This was a formula student team from Delft University. They decided there was a component for one of their cars that was a complex assembly of different parts put together, and they decided to, instead of machine this and then have to assemble it and waste so much time in that situation, to actually 3D print the part in titanium and DMLS. And they did so without losing any functionality and actually gaining time in production, of course, and in assembly, and simplifying their design overall. Another example of this, again, back to part consolidation, is this Opticis. Basically, they had this assembly for an antenna component that was an assembly of 100 different components that were manufactured with wire EDM. And of course, they needed these very small parts in wire EDM because of the manufacturing constraints. So they said, okay, why don't we use 3D printing for this instead? We have certain properties that we don't want to lose, like corrosion resistance or thermal expansion, of course, that are important for us. But if we have a material that can actually be used for this in 3D printing, then we would go for 3D printing. They tried it, tested it, and they essentially printed this part, which was a consolidation of 100 different components into one. They saved 9 months. They saved 25% of production costs and 75% of startup costs. So yeah, that was pretty impressive. And finally, this is quite common, is do I need this quick? So if you're doing a project and if the answer to the question of when do you need this by is yesterday, then probably you want to consider 3D printing for this. And again, it's important to kind of not fall in the misconception of that maybe the materials are not going to be right for 3D printing, because we have had a lot of development in materials for 3D printing. So always, if you need a part really, really quick, then always consider 3D printing. So a good example, again, one of our customers, they needed a very simple, small part. It was a cap for a USB key, and they needed runs of 500 parts per year. And of course, it's a small part in plastic. You need a few runs per year. What do you consider? Injection molding. So initially, they considered using injection molding and using nylon for these parts. But yeah, again, they needed the parts very quick. And after speaking to us, they realized that actually they could use industrial FDM printing instead and use the ASA material. And by using this, they actually maintained the properties that they needed. That was UV stability. And in addition to that, because we're using an industrial 3D printer instead of a desktop 3D printer, we actually also maintain the accuracy of the part needed. And because of this, we managed to save them almost 2 months of time and 4,500 euros of budget, which for this project was quite a significant cost. So yeah, these are the 3 questions to consider if you have any projects where you want to consider to use 3D printing instead of CNC machining, wire EDM, or injection molding. These are very top-level questions to always keep in mind when you're developing this type of projects. Yeah, that's it. If you have any questions, I'll be available afterwards. Thank you.